In this video, I am going to discuss again system of linear equations. This is part 2 of this lecture. And how can we solve a system of three linear equations in three variables? That's what I am going to discuss in this lecture. And you have three linear equation in three variables x, y, and z. It means you have three planes. Plane means a sheet of paper, for example. So there are how many possibilities? Like before in our last class I said when you are solving a system of two linear equations in two variables, there are exactly three possibilities. Either you will get a unique solution of the system, or you will get no solution of the system, or you will get infinitely many solution of the system. No solution, or the third possibility is infinitely many solution. Infinitely many solutions of the system. And for the unique solution, I said you will get two different values. For example, x equal to 1 and y equal to 2. You will get two different values for the variables, which indicates that the system has unique solution. And in this case, in the eliminated system, number of equation will be equal to number of variables. And no solution case, you will get a contradictory statement like this. During elimination, when you will find a contradictory statement like this, 0 equal to b, which indicates that the system has no solution. And for the infinitely many solution case, during elimination, one equation will convert it to 0 equal to 0, which means the number of variables will be bigger than the number of equation, because one equation will eliminate from the system, or two equation can be eliminated from the system. So graphically, you see three planes, three equations in three variables. It means three planes, and this figure indicates that there is no point of intersection of three planes, so no solution. And in this case, there is two planes are parallel, but there is no common intersection point, so there is no solution in this case. Or three planes intersect each other like this, still there is no common point, so no solution. And in this case, no solution, because two planes coincide each other and parallel to the third one, so no common intersection means no solution. In this case, there is a single point where two planes intersect each other, so the system has a single solution or one solution. And in this case, you see three planes intersect each other in a line, so the system has infinitely many solutions. And in this case, three planes all are coincident, three planes coincide each other, so in this case there is also infinitely many solutions. And here two coincident planes and intersect each other and intersect to the third one in a line, so in this case there is also infinitely many solutions. So you see, in this case, when you are solving a system of three linear equations in three variables, the possibilities are same. Either you will get a unique solution of the system, or no solution, or infinitely many solution. Now in this lecture, I am going to solve three system of linear equations in three variables, and one solution will be related to the unique solution, other one will be related to the no solution, third one will be related to the infinitely many solution case. So let us first solve this system to understand unique solution of a linear system in three variables. Here let us denote three equations by equation 1, 2 and 3. And first, what is our plan? our plan is to eliminate x from the second equation, and then we are going to eliminate x from the third equation. And in order to eliminate x from the second equation using equation 1 and 2, you must need to multiply equation 1 by 2, because x coefficients need to be same in both equations. So if we multiply equation 1 by 2, we get 2x plus 2y plus 3z is equal to 8. 2z is equal to 8, and equation 2 will be as it is, so it means we need to multiply by 1. That gives us 2x minus y plus z is equal to 3. Now let us subtract equation second one from the first one to eliminate x. X and x, 2x will cancel, and 2y minus y, it means 3y. 2z minus z, which means z, is equal 8 minus 3, which is equal to 5. So this is our fourth equation. 3y minus plus z is equal to 5. This is our fourth equation. And now I want to eliminate x from the third equation using equation 1 and 3. Note that you first need to use equation 1 and 2. Then you are allowed to use either equation 1 and 3 or equation 2 and 3. তুমি প্রথমে ইকুয়েশন 1 এবং 2 ইউজ করে x কে এলিমিনেট করবা। সেকেন্ড, তুমি 1 এবং 3 কে ইউজ করেও x কে এলিমিনেট করতে পারো from the third equation, or equation 2 and 3 ইউজ করেও third equation থেকে x এলিমিনেট করতে পারো। Here I am going to eliminate x from using equation 1 and 3. So equation 1 means x plus y plus z is equal to 4, and equation 3 means x minus 2y plus 3z is equal to 5. Now x and x will cancel. Y minus 2y, it means 3y minus 2z is equal minus 1, which is equation number 5. Now from 4 and 5 we can, you see equation 4 is in two variables y and z, and equation 5 is in two variables in which is y and z. So you can now eliminate y or z from 4 and 5. So since y coefficients in both equation is same, we just need to eliminate equation 5 from, we just need to subtract equation 5 from equation 4. So 3y minus 2z equal to minus 1. That gives us 3y will cancel, z minus 2z, it means 3z, which is equal 5 minus 1, which is 6. Therefore z equal to 2. And now by back substitution, if we put back z in either equation 4 and 5, we will get y. So let us replace z in 4. That means 3y plus 2 is equal to 5. 3y equal 5 minus 2, which is 3. Therefore y equal to 1. So now we can put back equation y and z in equation 1. That gives us x plus y, which is 1, plus z, which is 2, is equal to 4, and that implies x equal to 1. So the system has a unique solution because we got x equal to 1, y equal to 1, and z equal to 2. The solution is, therefore the required solution of the given system is equal this 1, 1, 2. Now let us solve another system for the no solution case, and in this case the system is said to be inconsistent. So the procedure is exactly same like before what I discussed just now. You see, first you need to multiply equation 2 by 2 and then subtract equation 1. So if you multiply equation 2 by 2 and subtract equation 1, that gives us 5y minus z equal to 7. তুমি চাইলে এরকম পাশাপাশি করতে পারো অথবা এইখানে আমি যেভাবে করলাম উপরে নিচে সেভাবেও করতে পারো। So this is equation 4, and now using either equation 1 and 3 or 2 and 3 you can calculate equation 5. Here I subtract equation 3 from 2 times 3, equation 2 times 3. Equation 2 times 3 I subtract from equation 3. That gives us 5y minus 5z equal to 10, which is equation 5. And you see 4 minus 5, or either 5 minus 4 or 4 minus 5, you can do that. And that implies 0 equal to 3 when you subtract 4 from 5, since left hand side is same. So you will get a contradictory statement like this, 0 equal to 3, which cannot be possible, which is an impossible statement, which indicates that the system has no solution. It means the system is inconsistent. And now let me discuss the third one. Third one is the consistent case, and in this case you will get infinitely many solutions of the system. And like before, using equation 1 and 2 you will get equation 4, and using equation 1 and 3 you will get equation 5. And you see equation 4 and 5 are exactly same. So if you subtract 4 from 5, you will get 0 equal to 0, which is true statement. But 1, it indicates that the third equation will eliminate from the system. So what we get here, equation 1 we did not do anything. We are trying to eliminate x from equation 3, and equation 2 in that case converted to equation 4. And when we are trying to eliminate x from the third equation, equation 3 converted to equation 5. So now you have equation 1, 4 and 5 in your hand, but 4 and 5 are exactly same equation, so forget about equation 5. It means you have two equations in your hand. So we can write that the original system means this system now becomes x plus y plus z is equal to 4, first equation, and equation 4, 3y minus z is equal to 0. So now original system becomes a system of two linear equations in three variables. This is called eliminated system or converted system. And you now need to decide from this system whether how many variable you need to consider as an arbitrary variable or free variable. And it depends on the difference between number of variables and number of equation. Here our number of variables 3 minus number of equation is 2 in the eliminated system. So 3 minus 2 equal to 1. It means one variable you need to consider as an arbitrary variable, arbitrary variable, or free variable, free variable. And note that you are allowed to consider either y or z as an arbitrary variable, and it should be from the second equation. In the second equation you have two variables y and z, so you are allowed to consider either y or z as an arbitrary variable. You see, we first consider z as an arbitrary variable, then we show what happened when we consider y as an arbitrary variable. You don't need to do two methods in the same problem. One method is fine, but let me discuss two of them. When you consider z arbitrary, it means your other variable should be in terms of z, like this. And this is the general solution, the required general solution of the system. Let me say it again. When you consider z as an arbitrary variable, you need to write y in terms of z and x in terms of z, since z arbitrary. And z arbitrary means you are allowed to consider any real value for z. What does it mean by z arbitrary? It means you are allowed to consider any value, any real value for z. Z is independent. You can remember these types of equation. When I say y equal to 2x plus 7, here we know y depends on x. It means x independent, y depends on x. Y is a dependent variable. So this x, we can say x arbitrary. X is an arbitrary variable. So you can consider any real value for x. Therefore, when z arbitrary, your y should be in terms of z and x should be in terms of z. And from second equation, y will be what? Y is equal z by 3. That's what I have written here. And from the first equation, x equal what? X equal 4 minus y minus z. And now you need to put y here to make x in terms of z, since y equal 1 by 3z. So here LCM 3 and 12 minus 4z. So this is the general solution of the given system. However, if you consider y as an arbitrary variable, then what is the general solution? Let me write it here. Y arbitrary, and you need to write z in terms of y, and which is 3y from the second equation. And from the first equation, x should be in terms of y, which is 4 minus y minus z, and this equal 4 minus y minus z means 3y, which is equal 4 minus 4y. So what is general solution? Y arbitrary, z equal to 3y and x equal to 4 minus 4y. You see, x equal to 4 minus 4y, z equal to 3y, and y arbitrary. Now other thing is particular solution. Particular solution we get from the general solution by putting any particular values to the arbitrary variable. For example, let's say y equal to 1. You are allowed to consider any real value for y, I said before. So when y equal to 1, x will be 4 minus 4 into 1, it means 0. And z will be 3 into 1, it means 3. So the solution is this 0, 1, 3. And let me check it here. What happened when z arbitrary and I want to consider 3 for z in this general solution. So if z equal to 3, y will be 3 by 3, it means 1, and x will be 12 minus 12 divided by 3, which is 0. So you see, this general solution and this general solution will give you same particular solution always. Therefore the solution is same, two solutions, two general solutions are same solution, but during exam you will write only this one, and your question if tells you to find two or three particular solution, you can calculate that by considering 3z, z equal to, for example, 0 1 2, then you will get corresponding three values for x, three values for y. This is how you can calculate three particular solution. So that's it in this lecture. So I hope you will not miss the next video, because next video is related to the applications of system of linear equations. Thank you very much.